All right, folks. So right now I'm going over the voting booth. That's different than the voting machine, or the voting majority votes game. The majority votes project is a little bit different. It did have 4 buttons, and it had 1 LED. This one's gonna have 2 LEDs, so we'll definitely need a second one right here. And for outputs, for the different outputs, we can actually have 2 outputs, or we're gonna have to have 2 outputs. Boy, these resistors are so huge. um, so it's going to be a little bit funky trying to get them in, but watch this. I can make it happen. So first off, we're going to put it maybe behind here. It's going to be funky. Maybe I'll put it over here just to make things a little bit easier for you to see. So there it is. And so this is pin 13. This is 1 LED. And this is my other LED. Oh look, I can make them different colors. So I'm going to make the alarm red and the booth light green. So this one does have 2. We'll talk about it in a minute. Like I said, this is a little bit crowded, but we'll make it happen. So let's see. So here's the LED. The ground right here definitely just needs to go to ground. That's going to be easy. And I think I used pin 11. But I'll have to stare at my code here for just a second. What I do, yeah, I used 11. I used 11 for the alarm light. So this one right here is going to be my alarm. So I'll actually make this one my alarm over here. Delete. And just so we're not crisscrossing wires. So here's my alarm. It goes here and it's red. This one right here is going to be green, and this is going to be my booth light. And the only way to do this, really, so it's not so crowded, is I'm going to do pin 13 up to, I'll do it to here, and it goes from here to here. So if you see pin 13 goes here, it goes in here, goes in here. Yes, it does go in this row as well, but there's nothing there anyway. So it goes in here, comes out here, then goes down to there, okay? And if you see, it comes in here and it goes into this row to the positive where it's supposed to go. So it's still going to the right place. It's just a little like a longer path is all. And so here's my alarm. Here's my booth. And you can, if you ever wanted to, you can actually name this, I think, alarm. And you can name this booth if you wanted to. So those are my 2 outputs. And to remind you of this, this is the 2 logics for that project that we had last semester, okay? So we have booth, and it's not A and B, or not C and D. That's all the logic there was for booth. For alarm, it's AB, or BC, or CD. And remember, these are technically ands when we put a dot between them, right? Because technically these have dots between them, right? Like this and this. So these are what looks multiplied, but in logic that just means A and B, or technically because they're inverted with the knots. So it's not A and not B, or not C and not D. And this one's AB, or BC, or C and D. All right. So once we have our logic expressions and we have our wiring done, you need to go over here to Arduino, and we need a name for variables. I named them A, B, C, and D for the 4 booths. Then we have to have 4 inputs. Those are where our buttons are going to wire to, 2, 3, 4, and 5. And 5 is going to be my president. Sorry, actually, there's no president in this one. I'm sorry. So they're just all the same, A, B, C, D. So it's pins 5, 4, 3, and 2. Let's double check that I do have that correct. Am I using 5, 4, 3, and 2? Yep, for my A, B, C, and D booths. Yep. So all is good so far. And I have 2 outputs this time. I have a booth light and alarm light. Okay. And the first thing we're going to do, so all this does is just tell the Arduino which pins we're using and whether they're going to be inputs or outputs. And then this sets up my 4 variables. I didn't even set them to anything. I know a lot of times we set them equal to something, right? Like we say equal to 1, but I don't need them to be on or off. I don't really care. It'll read the pins and set them to 1 or 0, high or low. It'll set them once it reads them, right? So that's the 4. So here's our loop. I can delete this line of code, that comment right there. So here's the open, and here's the close right here. So all my code goes here in loops. And the very first thing I do is just read the four things. So if I want to, I can say, write a note, put read the four button pins and set the variables. So in other words, just read these pins and set the variables to whatever they are, whether they're being pushed or not, right? And then the next code right here is, I guess this little section of code, this if-else statement is going to be, let me give it a little bit more space here too. This is for the booth logic. And it's right here. And it looks a little confusing, but it's not. This is just exclamation points is how you write the not symbol, you know, the line above the A. So it means not A, and then and, you put two ampersands, which is, what is it, above the 7, right? So the symbol above the 7, you have to push shift and then that. You put two of them, and then you put and not B. All I'm doing is putting this right here. That's this one right here. And then I put or, the two bars, and for me, that's the little bar. It's kind of below, there's a key right below, it's on the right side of your keyboard, and it's below the backspace or delete button. I'm not sure what it is on your keyboard. It's usually a backspace. And then as above the enter, and it's kind of in between, and there's like a little bar. You have to kind of push shift, and then that button to get that. And you put two of those, and that means or. So that means or. And then I have not C and not D, which is exactly what this is right here. I just put that symbol there. Okay. And then, of course, I put this little, both those, this not C and not D, I put it in a parenthesis. And I put this in a parenthesis. And then the if statement itself, when you write the if statement, it has to be in its own parentheses. So we have this one right here. You see the yellow? And then we have this, this last one in yellow. So the whole thing has to be in a parenthesis always. And then we write our, what's called our statement in here. And I'm just saying that if this is true, if this statement that's in yellow is true altogether. And to understand this, you just have to say, okay, if you take A and do the opposite of it, and B and the opposite of it, and if they're both true, okay, good. Or if these are both true. So technically they'd have to both be false though, right? Like this one would have to be false and this one would have to be false, because then we're putting a not, the exclamation point. So anyway, it's just part of logic. So if this is true, this statement is true, we're going to turn the light on for pin 13, because this is our booth light, right? Pin 13. So we're going to turn the light on. Otherwise, else, we're going to turn it off. That's all this statement says. Then, of course, we have our second one right here, and this would be the, I'm going to put a note here, this is the alarm logic. And this one is, what is it, A and, where's my and, there it is, and B, or it's B and, where is it, C and D, C and B. It's C and B, isn't it? Let me just double check before I write this. A, B, B, C, C, D. There we go. So A, B, or B and C, or C and, put two and signs, D. And that's it. Now, except for one thing. I'm not 100% sure it'll work like this. You can try it if you want, see if you get an error. But I always, for the safety, just put a parenthesis around this, because this is one term. And then this is another term. And this one right here, this last one, the C and D, is another term. And the terms are all or together, right? There's an or here and an or here. And of course, the whole thing is in this parenthesis. This yellow one here at the beginning and this yellow one at the end. That's the entire statement. So the entire statement is technically this in yellow, and I have a parenthesis here and a parenthesis here. All right, so there's my line. So if that's true, we're going to turn a light on, right? So I'm gonna need to open curly bracket and then enter. I get it. I should have two now. There we go. I want to put some space here so you can see. There we go. So I have this statement, and if it's true, inside these two brackets, I'm going to put my code, and I'm just going to put digital write pin 11. That's my alarm. And I'm going to say turn it on. That's it. Except if it's not true, else, and then put the curly brackets, turn it off. Digital is lowercase, capital W, R-I-T-E. Make sure that's exactly spelled that way or it won't work. And then 11, pin 11, we're just going to turn it off if it's not true. That's all. And that's pretty much it. You know, so I have this one right here. So if you look in a loop, because this is our loop right here, right? Let's see if I can put this on another line for you. Here's our beginning of our loop, and here's the end of our loop. You can see they put a box on it. And all it does is it sets the 4 variables, then it immediately checks to see if this statement is true. If it is, it turns the light on. If it's not, it doesn't. Then it checks this one to see if this is true, and it'll turn this light on if it is. Otherwise, it turns it off. And then it loops right back, constantly doing this every millisecond or multiple times per millisecond. And always checking these buttons. It's always analyzing these buttons, then checking these logics and setting the thing high or low depending on whether this logic is true or not. And that's all there is to it, folks. If we copy and paste this, it should work. I think I have semicolons everywhere need be. And I go copy. And we'll go over here to code. And we'll delete this one. That was my president one. And let's see, start simulation. No error so far. The green light's already on. I don't know if you guys can see that. The green light is already on. And the reason being is there's a booth available. There's nobody in any of these booths, right? So if I hold shift down and I'm going to click this one and this one, this light should turn off. Here, here. There we go. No booth available. So there's no booth available. There's somebody here and there's somebody here now. I'm going to go ahead and click to undo it. There we go. Now, there we go. So now all the booths are available. Nobody's in any of them. And I'm going to put somebody voting right next to each other, and that should set the alarm off. So let me hold shift, and I'm going to click this one, and I'm going to click this one. There we go. There's an alarm going off. Reason being is there's 2 people voting next to each other, and they're not supposed to. That's one of the rules. So how did we get those logic expressions? I don't know if it's been a while, but how did we get these? Well, we needed truth tables, and then we just put whether there's going to be 1s or 0s on each row, right? Because we just decide with the rules whether or not they should be on or off. And then we write down the minterm for each one and write down the big long logic expression. Of course, you would want to simplify it, and these are simplified. These ones are already simplified. And we simplify using K-mapping or Boolean algebra, or you use a Boolean calculator and you just type the long term in and it'll simplify it, right? That's just a review from what we did past last semester. And that's it, folks. So that's how you build the the voting booth machine, okay? And that's it.